All right, gang. Today is just going to be a quick one. We've talked about the Henderson-Hasselbalch equation. Last video we showed what adding a strong acid or a strong base can do to the pH of a buffer. Today we're just going to do a quick, very quick problem talking about the what happens to the pH if you add another weak acid. Okay. So let's say for this example problem, we've got a buffer of acetic acid and acetate. Okay, they are in equal concentrations of 1 molar in a 1 liter solution. We add 50 milliliters of HF. Okay. And it is, let's say, 2 molar HF. We want to know what the change in pH would be. So in a strong acid or base question, we would just take the molarity here with its volume, find the number of moles, and then subtract and add from the number of moles here. However, we can't do that because the number of moles of HF and the number of moles of H plus are not going to be the same for a weak acid. Okay, so what we have to do is we have to do a quick ice table. So I, C, E, we have HF, H plus, and F minus. Okay, now we are starting with 2 molar HF. Then we have 0 and 0. Our change will be minus X, and it'll be plus X and plus X. And so our equilibrium concentrations will be X, X, and 2 minus X. Okay. Now we need to plug that into our Ka for HF, and the Ka for HF is 6.6 times 10 to the negative 4th, and that is equal to our x squared over 2 minus x. Okay, now we are within the range of doing an approximation, and so that 2 minus x is just going to end up being 2. When we solve this, we get x, which is our concentration of H plus, is equal to 0.0363. Okay, so that is our concentration of H plus in our 50 milliliter solution. So what we need to do is then we take our concentration here, which is 0.0, I'll erase that, 0.0363 molarity is equal to X number of moles over 0.050. Okay, when we solve that, we get 0.00182 moles of H plus. Okay, now that's how much H plus is going to be added to our solution. When we add that, we can say we then need to subtract and add to our concentrations of A minus and HA. So A minus is going to subtract 0.00182, and HA concentration is going to add 0.00182. And so we then get, for A minus, put this in green, A minus concentration is equal to 0.998. I think it's 8. I think it's 7, 8. Let me check. There we go. So now we have to do our Henderson-Hasselbalch equation. And so we get the pH is equal to the pKa, which is the negative log of 1.8 times 10 to the negative 5th, and added to log of 0.9982 over 1.00182. Okay, and that is equal to, all right, so I simplified it a little bit. We've got the negative log, the pKa of acetic acid is this, and then the log of 0.99 over 1.00 is equal to this. And so there's not a very large change, okay? You need a lot of weak acid to change the pH of a buffer, okay? So this is what you got to do. It's a quick example problem. It's a little bit more work, but that's how you solve a addition of a weak acid to a buffer, okay? And then if you add a weak base, you would have to do the same thing, but with a Kb here instead of a Ka, and you would be adding here and subtracting here. Okay, so take that, ask questions if you need it.